Hello everyone, welcome. Before understanding what is cap theorem, we need to understand partition and partition tolerance. So consider a scenario where application server nodes are connected with each other. Okay. Now because of some disruption or some network failure, node B gets disconnected from another nodes in the network. Okay. So this leads to formation of two different subnets, two independent subnets in the network. Okay. One subnet is this node B, and another subnet consists of node A and node C. Now users are still connected to these two subnets. Okay, so these two subnets start operating independently. Okay, they are still responding to users and they are still getting return by the request from client. What is meant by partition tolerance? Partition tolerance means in spite of having partition in network, the system should remain operational. Okay, that is, if users come and request some data from B, the node B should be able to respond. If users come and request data from node A or node C, they should be able to respond. That is what is meant by partition tolerance. Now let's see what does cap theorem say. So cap theorem says that whenever you have to select between availability, consistency and partition tolerance in a network, you can only choose two of these properties. You cannot choose third one. You can either choose availability and consistency, you can choose availability and partition tolerance, and you can choose consistency and partition tolerance. You can choose any of these, but not all three at any given time. Now in ideal world there would be no network partition, but in real world network partition will always exist. You cannot guarantee that there would not be any partition. No matter how much ever resources you put, there is going to be network partition. It could be because of anything. You never know how would network disruption happen. So network partition is always going to happen. And in a real world system, you will always have to guarantee partition tolerance. Okay? Because you have to always guarantee partition tolerance in real world systems, you can choose to give availability with partition tolerance and you can choose to give consistency with partition tolerance. So that means in real world system, availability and consistency cannot be simultaneously guaranteed. Now let's discuss why availability and consistency cannot be simultaneously guaranteed in a system. Okay, so we'll consider the same case of network partition, and users are still connected to the subnetwork AC and subnetwork B. Okay. Now let's say there is a write request. And this write request is coming from a client that is connected to node B. So if we allow the client to write on node B, then the data present on node A and node C would be stale data. Now at the same time, if there is a read request and this read request is coming to this particular network partition or subnet, the data they are going to read is stale data. Now in this particular scenario, if you want to guarantee consistency, then all the write requests should be stopped. Your system should not allow any write requests. What does that mean? It means that your system is not available for write requests. So if you want to guarantee consistency, you cannot guarantee availability. On the other hand, if you want to guarantee availability, then you will have to accept all the write requests. So if the client writes on B and another client wants to read from A or C, then the data present it on a stale data. Because you are guaranteeing availability, you cannot allow it to not read from A or C. So you are guaranteeing availability, but the data that is being written over node B and the data that is being read from node A or node C is inconsistent. So when you are guaranteeing availability, you cannot guarantee consistency. So in real world, you cannot guarantee consistency and availability simultaneously. I hope you would have understood this. Thank you.